All right, this is going to be kind of quick, but I'm going to give you all the pieces that you need to finish this. I'm not going to actually do it for you, though, okay? All right, so a radial arm saw has a circular spinning cutting blade with a diameter of 10 inches. That means our radius is 5. I'm going to give you a hint since this thing is spinning and we're talking revolutions per minute. We will want our circumference here. So the circumference formula, you should know the circumference formula. Yes. Hey, and what's the relationship between the circumference formula and the special angles we've been talking about? 2 pi is all the way around in what units? Radians, which is what r is, right? All right, so 2 pi r, so r is 5, so your circumference then is 2 pi times 5, 10 pi. All right, you're going to need to know that. And units, were these in inches or inches? 10 pi inches all the way around. Give me an estimate on that. How many inches is that all the way around? 35-ish? A little less than that, but pretty close. 31.4-ish inches. All right. 35 is a great, like, hey, quick, you're in the ballpark. All right, let's, what do they want? What did they tell us? What else did they tell us? 2,000 RPMs it's spinning. So I would write that as 2,000 revolutions per 1 minute. That would be one of my fancy ones that I could use in my conversion. This is going to be a conversion problem, I'm pretty certain. And there are 12 cutting teeth per inch. So 12 teeth per 1 inch would be another fancy one that I could use. In the context of this problem, 12 teeth and 1 inch represent the same thing. And then it says how many teeth cross the cutting surface each second. So I am going to try and do a conversion problem where my final units end up being how many teeth cross the cutting surface per second. And I'm going to start with, I think I'll start with this because it's got minutes on the bottom. That's a unit of time. I think I can convert that. So 2,000 revolutions, rev, per 1 minute. I think I should then be able to convert minutes into seconds. That'll be relatively simple. I'm going to have to convert revolutions into teeth. I've got a conversion between teeth and inches. What's my conversion between revolutions and inches? 10 pi inches is the same thing as how many revolutions? 1 revolution in the context of this problem. So we're going to end up using this and this and then like seconds into minutes. So you'll end up with 3 more fractions here that will get you where you need to go. And I'll let you guys finish that one up. What else can we talk about? Yes. 43 from the same section. Navigation. Yep, so I'll kind of get you started on this. They gave us a picture in this, which was nice. When we're doing navigation, we measure the angle from due north, and we go clockwise around instead. So you got these 2 ships that are heading out in roughly the same direction. One of them is in a heading of 42 degrees 30 seconds. Now 42 degrees 30 seconds, I'm hoping you can turn into degrees as a decimal. That's 42 point what? 0.5. 30 seconds is half of a degree, right? Because there's 60 seconds in a degree. 42.5. We already learned how to do that with the calculator. We didn't have to do that in our head, but we were capable, so we'll practice there. And then this one was 52 degrees 12 seconds, so I would take my calculator and do 52 plus 12 over 60, which comes out to 52.2. So this is 52.2 degrees. So I'll show you how to finish this up, okay? you're going to need to find this angle. I'm going to call it theta. And that should be pretty easy because you've got two angles that kind of subtract to give you that, right? So you're going to find that, and then you're going to think about a wedge with theta as your angle. They told you that they both went 25 miles, so the radius would be 25. And they're asking how far apart they are. In navigation, a lot of times when we're doing distances, they'll use an arc length instead of a straight line distance. That's going to be our S. Now, since theta is in degrees, we're going to need to use this formula, S equals, well, I'll let you guys look it up. It's got R and theta in it, but there's also a fraction out front. I want to say it's pi over 180. But I'll let you guys look it up. So you just need to plug some numbers in there, and that'll get you your answer. So they're really kind of disguising an arc length problem with the way they describe this. All right, do you feel confident you can finish that? All right, what else can we talk about? From the review or from 4.1? From the what? From the most recent one? Yeah. Yeah. Let me grab a copy of that. Number 7 from the packet that we started on Friday. So we've got the graph, we've got to write a function, number 7. P7. This the one here? Oh man. Wait, is this? That's today's packet. How did that end up in there? I was about to say, I gave you the wrong packet if I gave you that problem. Let's try again. P7. This one. Almost there. This one right here? Yes? Do I have the right one? Okay. Sorry for the delay. Thanks for your patience. Yeah, this one's kind of weird because they don't give us a whole period to look at. So I'm gonna make myself a little sketch of one full period, and I'm just gonna I like to make a quick sketch and label some numbers on it. First of all, when you look at this and you see it passing through the origin, what does that make you think? Sign, and it's going upwards first, so positive sign or negative sign. We're thinking a positive sign, and we know that a positive sign is going to look like this. And what I can see on my graph is that it starts at 0, as everything we've seen so far. And then this point right here would correspond to kind of halfway through my period, where it's crossing that x-axis again. And that happens at 3. So I'm going to use the fact that there's symmetry in these to say that my period is going to be 6 for this. So the period is 6. Amplitude looks like is just 1. It's a positive sign. We've got all the pieces we need. So I'll leave the rest to you. Are you guys comfortable going from period to omega? Omega would be 2 pi times the reciprocal of the period. 2 pi over 6 is pi over 3. Cool. Thanks for asking about that one. That one was kind of messy. You're going to see some today where it might only show you like this point and this point are all you're going to be able to see. But that'll be enough because you're just going to sketch it out and you're going to be like, oh, if this is at 0 and this is at 4, then this must be 8, 12, 16, right? So just make that little sketch of the whole period and start labeling and you'll be able to figure stuff out pretty quickly. What other questions do y'all have? Anything from the review, the 4.1, 4.3 review? Did we do all right on those last 6 problems? I'm going to be checking those today. I did post the full solution set for the, not solutions, answer set. That's on Canvas. If you look at today's entry on Canvas and the due today, the full key is there. So if you want to check, I had the odd numbered solutions up last week, but if you wanted to check the even numbered problems and make sure you're doing those correct, I highly recommend that at some point. Come in and ask them. Yeah, the 4.3 review. Or 4.1 to 4.3 review. I don't have like work and steps for it, but I have answers for all the odds and evens up now. No, okay. So we're looking at the 4.1 to 4.3 review. I don't have a copy of this in front of me, so someone's going to have to read me some problems. 4.1 to 4.3. This is like our mid-unit review. By the way, our test is coming up. It's going to be not next Friday, but the Friday after that. So we have four more lessons, and then we'll have 2 in-class review days. Although one of those is a half-day Wednesday. I want to say March 8th. Not this Friday. Not next Friday. Yeah. Yeah. This Friday is the 23rd, and next Friday is March 1st, and our test is on March 8th. 2.5 weeks. 2.5 weeks. Lots of time for our thespians to recover from their excruciating weekend. You guys are going to do awesome. Can't wait. My mom's looking forward to it too. All right. She loves going to the plays. I take her every year. So she's still talking about Les Mis from last year. We saw Les Mis in Toronto when I was like, I think I was in high school, and there was like the original Jean Valjean cast member was in it. The guy who, like, when they opened on Broadway. And it was cool. It was awesome. But she was like, you guys did better. So, yeah. All right. Give me, which one do you want to do? You get to choose. 18. All right. Can you read me the pieces? It's a picture. Radius of 20 feet, and let me pull it up here. Okay, they're asking us to find the arc length, right? Cool. And they gave us a radius. So they gave us the radius is 20, and they gave us that theta is 3 pi over 2. So you just need to know the formula. This is just plugging into a formula. S equals, and it depends on whether your angle is in radians or degrees. If it's in radians, it's just that one. If it's in degrees, it's the pi over 180 r theta. I need you to know those. And those of you who are doing CWU, I think I talked about how you also need to know the sector area. I will not be testing you on that, but it usually comes up in the CWU exam. That's area equals, oh geez, a half times r squared theta, I think. You might want to check that. And pi over 360 times r squared theta, but you might want to check these big question marks. But for ours, we just need to plug the 20 and the 3 pi over 2 in there. So 20 over 2 is 10. I think we're going to get 30 pi. So make sure you know these 2 formulas. And then make sure, if you're doing the CWU exam that you review, check and make sure these are right. I'm not 100%. I'm not a good formula collector. All right, thank you for that. What else? We got time for one more, and then we should probably get started on our new stuff. I've got a couple assignments I need to check today, so I need to leave some time to do that. Going once. Twice. All right, I'll tell you what, if you have your little half sheet self-assessment,